Very good morning to one and all. Welcome to the lecture series Principle of Communication Engineering, class 2nd year Electronics and Telecommunication, sem 3rd. Today we'll start with the module number 3, angle modulation in demodulation. In module number 2, we dealing with the amplitude modulation and demodulation. We see in previous lectures various types of amplitude modulation and demodulation, applications, advantage, disadvantage, various modulator circuit and demodulator circuit of amplitude modulation, comparison between amplitude modulations and various techniques. Today we will start with the angle modulation and demodulation. In this lecture, first we introduce the concept of frequency modulation and phase modulation, basic concept and mathematical representation and waveforms of phase modulation and frequency modulation. So let us begin with the frequency modulation. Frequency modulation. In frequency modulation, frequency of the carrier signal, that is C of t, changes with respect to the modulating signal, that is M of t. So frequency of a carrier signal can be changed with respect to the modulating signal. Here the amplitude of a carrier signal will be constant. That is the biggest advantage of the frequency modulation. So if you have carrier signal C of t is equal to, in time domain representation, E of c cos omega c of t into phi, where phi is a phase, and we have the modulated signal M of t. So f frequency of M of t into, then we can write E of cos of t 2 pi fct into phi of t. So we can write in terms of theta. So E of c into cos theta t. So frequency modulation, we can write down theta of t is equal to 2 pi fct plus 2 pi kf integration 0 to t into x of t, where x of t is a modulating signal. So modulating signal, the output we can write down in terms of this theta value here. So we get modulating signal y of m of t in time domain ec into cos 2 pi fct plus 2 pi kf 0 to t integration x of t into dt, where this kf is a frequency sensitivity, which is unit hertz per volt. So how to generate this frequency modulated signal? So here the integrator, then phase modulator. So modulating signal, which is x of t, is applied to the integrator. Over integration we get 0 to 2t. So in time integration, so over a time interval 0 to t, x of t, which is applied to the phase modulator. Phase modulator which generates a frequency variation in FM waveform. So carrier which add the frequency of modulating signal plus carrier signal which generates the FM waves. So output of this is nothing but the cos 2 pi fc plus 2 pi kf integration x of t into dt. This is nothing but the FM modulation. Now if we see the waveform of this modulating signal, so here this is the modulating signal which is to be modulated. So here the basic equation of the FM waves in time domain, y of fmt ec cos 2 pi fct plus 2 pi kf over integration 0 to t x of t into dt. So this whole term is called as a deviation of a frequency, which is denoted by delta f. So delta f may be positive and negative. It is depending upon the amplitude of the modulating signal. So if the delta f is positive, if the amplitude is positive, delta f is negative if the amplitude of the modulating signal is negative. So where the frequency deviation or deviation of the frequency is 0 when the amplitude of this carrier signal or modulating signal is 0. So we can see here there is no deviation of the carrier signal. So whenever the amplitude is maximum, the frequency separation is less. So frequency of modulating signal f is equal to fm fc plus delta f, that is the maximum. There is no separation of the frequency. Whenever the frequency deviation, that is 2 pi kf 0 to 2 t x of t into dt, that is nothing but a frequency deviation which is negative. So frequency is of the modulating signal, output of the modulating. So fm is frequency, fc minus delta f. So here is a more separation will be allocated. So this is about the frequency modulation. How the frequency modulation is done? So there is in two terms of, first is a sensitivity, that is kf, and second one is a delta f, that is frequency deviation. So frequency deviation 2 pi kf integration 0 to 2 x of t into dt. So depending upon the frequency deviation, the modulating frequency may be maximum or minimum depending upon the positive or negative amplitude of the modulating signal. Now then we go to the phase modulation. So what is meant by phase modulation? So phase modulation, the phase of the carrier signal changes with respect to the modulating signal f of t. If we have a carrier signal, c of t is equal to, in time domain, ec cos omega ct into phi. So ec cos 2 pi f ct into phi, where phi is a phase. So we can write down this ec cos into theta of t. For the phase modulation, the modulating signal, we have m of t. So theta of t is equal to 2 pi fc into t plus kp into x of t, where x of t is a modulating signal. So pm waves we can write down in terms of time domain. So y of pmt ec cos 2 pi fct plus kp into x of t. So where kp is a phase sensitivity which is measured in radian per volt. So this is to be remember what is meant by kf, what is meant by kp. So kp is a phase sensitivity. Now if we see the waveform of the block diagram, how to generate the phase modulation. So modulating signal, that is x of t, is applied a differentiator, that is dx by dt. So here the output is a differentiated modulating signal which is applied to the frequency modulator. The frequency modulator which add these two phase and generate the phase modulating waveform. So output is of this is y of p of t ec cos 2 pi fct plus kp x of t, where this term kp x of t is called as a deviation of phase, that is delta phi. So here we see that the waveform of the pm waves. So this is the modulating signal where the phase for the carrier signal is 0, where the phase is maximum for if the amplitude is maximum, and where the amplitude is negative, that the time the phase is phase deviation is minimum. So whenever the phase deviation is positive, that means the PM means phase modulation leads with respect to carrier wave or carrier lags with respect to wave. So here we draw the waveform, that times we observe that the phase deviation is 0. So there is no separation of frequency or no resistance frequency of currency. So whenever the phase deviation is maximum or positive, that time the frequency separation is more. So this is a vice versa condition in frequency modulation, in phase modulation. Here whenever the frequency deviation is maximum, that time there is no separation of the frequency, and here the frequency separation is PM is maximum. Similarly, whenever the deviation of phase is negative, that times we say that the PM waves lag with respect to carrier, or carrier leads with respect to waves. So we can draw this waveform in this way. So in this lecture we discuss about the basic concept of the frequency modulation and phase modulation, which is a form of amplitude modulation and demodulation. So basically we see here the basic concept of FM and PM, mathematical representation of PM and FM waves, and waveforms of the PM and FM waves. So in this lecture we discuss about all these things, basic concept related to the PM and FM waves. So we can stop here. Thank you very much.